Springs in series. Here we have two springs. First of spring constant K1 and second of spring constant K2 connected in series. Both are attached to a mass M. A force mg pulls the system downwards. X1 is the extension produced in the first spring and X2 extension of the second spring. According to Hooke's law, a restoring force is produced inside the spring. Force produced in the first spring by Hooke's law, F1 equal to minus K1 x1, where K1 is the spring constant and x1 is the displacement. X1 equal to, from this equation, minus F1 by K1. Similarly, force produced in the second spring, F2 equal to minus K2 x2, where K2 is the spring constant of second spring and x2 the extension. From this equation, x2 equal to minus F2 by K2. Since both the springs are extended by same force, F equal to F1 plus F2. That is, instead of F1 and F2, we can write F. Let Xs be the total displacement. It will be equal to x1 plus x2. Instead of x1, we can write minus F1 by K1. Instead of x2, minus F2 by K2. F1 and F2 both are equal to F. So we can substitute F instead of F1 and F2. Now Xs be the resultant displacement. It is equal to the force F by Ks, where Ks is the resultant spring constant. From both these equations we can write minus F by Ks is equal to minus F by K1 plus minus F by K2. We can cancel minus from the three terms and also F from the three terms. Now we get 1 by Ks is equal to 1 by K1 plus 1 by K2. Due to force mg, both these springs are extended. These two springs are connected in parallel. Let K1 be the spring constant of first spring and K2 of second spring. Due to the force mg, the spring exerts a force upwards. F1 is the force exerted by the first spring and F2 by second spring. By Hooke's law, F1 equal to minus K1x and F2 equal to minus K2x. Extension of both the springs are same since they are connected to the same mass. Now total force, that is the equivalent force when the two springs are connected together, Bf. Then we can write F is equal to minus Kpx, where Kp is the resultant spring constant. Here net force F is equal to F1 plus F2. Instead of F we can write minus Kpx. Instead of F1 minus K1x and F2 minus K2x. We can cancel minus from the three terms and x also from the three terms. Now resultant spring constant Kp equal to K1 plus K2. The springs shown in figure are pulled by a force F on the mass M. Find the resultant spring constant. Here we have two springs K2 and K3 connected in series. So the resultant spring constant Ks with the resultant spring constant 1 by Ks is equal to 1 by K2 plus 1 by K3. That is Ks is equal to K2 K3 by K2 plus K3. Now the new spring here have a spring constant Ks. This Ks and K1 are connected in parallel. Now resultant spring constant Kp is equal to Ks plus K. Ks is equal to K2 K3 by K2 plus K3. On adding, we get K2 K3 plus K1 into K2 plus K3 by K2 K3, that is Kp equal to K1 K2 plus K2 K3 plus K1 K3 by K2 plus K3. So this is the resultant spring constant.